Okay, today we're going to talk about using the quadratic formula to solve a quadratic equation. So this is something you would use if you could not factor the quadratic equation. Keep in mind it will work even if it is factorable, but you would have to use this or completing the square if it wasn't factorable. So let me show you how it works. Remember the general or the standard form of a quadratic equation is just ax squared plus bx plus c equals 0. So a is our constant term, a is our term in front of x squared, b is our term in front of x, and c is our constant term. And here is the formula. This is something that you're going to want to make sure that you know because it will come up in this class and beyond. So the formula is this: x equals a negative b plus or minus b squared minus 4ac all over 2a. So that's the formula. The a, the b, and the c come from the quadratic equation. So I'll do a couple of different examples so you can see how it works. In my first example, my quadratic equation is x squared minus 5x minus 14 equals 0. Okay, so what I like to do is I like to write out what my a, my b, and my c values are. So my a value here is 1. Since there's no number written in front of x squared, then I know that it's 1. b is negative 5, and c is negative 14. So now all I'm going to do is plug into my formula. So I have x equals negative b, which is negative 5, plus or minus the square root of b squared, so negative 5 squared, minus 4 times 1 times negative 14. All of that over 2a. So that is the setup for the quadratic formula. And what I'm going to do then is I'm going to put that into my calculator. When you put it in your calculator, you can literally put it in exactly as it's written. So what I will do is I'll put I'll put what's under the radical in first, just the way that it's written. So I end up with parentheses, negative 5, closure parentheses, squared, minus 4 times 1 times negative 14. And that gives me 81. So I end up with x is equal to negative times a negative is a positive, so 5 plus or minus the square root of 81 over 2 times 1, which is 2, right? So I could have put 1 in here for a. 2 times 1, which is 2. Square root of 81, I know that's 9, so I end up with 5 plus or minus 9 over 2. So in fact here I have two answers. I have 5 plus 9 over 2, and I have 5 minus 9 over 2. So when I solve this, I get 14 over 2. So one of my answers is x equals 7. And my other answer comes out to be x is equal to negative 2. So it's not a difficult formula to use. It's just knowing what goes where in the formula and then solving it from there. We'll try another example. Our next example, the layout is going to be a tiny bit different, but we're going to solve it exactly the same way. In this example, I have 2k squared plus 9k equals negative 7. Now, The first thing is it doesn't matter what the variable is. It could be x, could be m, could be p, it could be r. It doesn't matter what the variable is. You're still solving it using the quadratic formula. Instead of x equals, it's just whatever the variable is. So in our case, it'll be k equals. But the one other important thing you want to do is make sure you have all of your terms on the same side of the equal sign. So the first thing I'm going to do is add 7 to both sides so I can move that 7 over to the other side. I know my a value is 2, my b value is 9, and my c value is 7. Here's my formula. X equals negative b plus or minus square root of b squared minus 4ac, all of that over 2a. So here we go. I'm just going to plug in now. In my case, my variable is k, so I'm going to use a k. So I have negative 9 plus or minus the square root of 9 squared minus 4 times 2 times 7. All of that over 2a, so all of that over 2 times 2. Using my calculator, I'm going to go ahead and put in what's under the radical. So I have 9 squared minus 4 times 2 times 7. And that gives me 25. So now I have negative 9 plus or minus the square root of 25 over 4. The square root of 25 is 5, so I'm going to replace that. So I have negative 9 plus or minus 5 over 4. So again, I have two solutions here. Okay? I have negative 9 plus 5 over 4, or I have negative 9 minus 5 over 4. So negative 9 plus 5 would be negative 4 over 4. And so k would be negative 1. That's one of my solutions. And here I have negative 14 over 4, which comes out to be not a whole number. It comes out to be a fraction, and that fraction comes out to be 7/2. So k is equal to negative 7/2. If you wanted to, you could write it as a decimal. That's the same as k equals a negative 3.5. You can write it either way. But those are your two solutions. So sometimes you get integers, sometimes you get fractions. Sometimes you're going to get a solution that's not rational. You're going to have an irrational component to it, meaning what's under the radical is not going to be a perfect square. Let's do one of those examples. I have 9n squared is equal to 4 plus 7n. Again, I want to get all of my terms on the same side of the equal sign. So I end up with 9 squared minus 7n minus 4 equals 0. So all I did was move these two terms over to the other side. My a value here is 9. My b value is negative 7. And my c value is negative 4. And again, I'm just going to plug into my formula. Here it is one more time. X equals negative b plus or minus the square root of b squared minus 4ac. All of that over 2a. So I have negative 7 plus or minus the square root negative 7 squared minus 4 times 9 times negative 4. All of that over 2 times 9. So this would give me positive 7, and now I'm going to figure out what number I end up with under my radical. Again, I'm going to go right to my calculator and do it there. So I have parentheses negative 7 squared minus 4 times 9 times negative 4, and that gives me 193. It's 193. All of that over 18. Now the reason that I don't put the square root in the calculator is because, let me pull my calculator up, is because if I put it in, then I would get this crazy decimal here, and I don't want it to be a decimal because a decimal is an approximation and I want the exact answer. So I don't put the radical symbol in the calculator. All I'm putting in there is the part that's under the radical so I can calculate what that's equal to. Now, I cannot simplify square root of 193. It's not a perfect square. There's nothing that goes into it that's going to help me out at all. So that's going to be my final, I'm not going to simplify square root of 193 in any way. So here are my two solutions. I end up with 7 n equals 7 over 18 plus radical 193 over 18. That's one of my solutions. My other one is 7 over 18 minus radical 193 over 18. Okay. Sometimes you'll see it written like this, 7 plus square root of 193 over 18, and 7 minus square root 193 over 18. You can write it either way. They're both correct. You can write it as two separate fractions or as one big fraction. Either one of those is totally acceptable and totally fine. So those are 3 different examples of using the quadratic formula, how you go about using it, how you plug everything in, and then reducing it at the end. Have a great day, Sebastian. I'll see you next time. Bye-bye.